Okay, tonight we're going to be talking about the theory of plate tectonics. Now, the Earth's lithosphere is divided into plates that move on top of the asthenosphere. And these broken pieces, each broken piece is called a tectonic plate. Now, we can think about a tectonic plate being like this guy here on the raft, and he is representing the lithosphere, and he is floating around, able to move on top of the asthenosphere. Now, the map here shows us the 10 major biggest plates, the biggest pieces of the crust, and where you see the red lines are where those pieces come together. And where the pieces come together is where all the action is happening. So those are called the plate boundaries. And if you look at this map here, all the plate boundaries are in yellow. You can see that most of them are on the oceanic crust. The oceanic crust is thin and therefore weaker. And if something is going to break, it's going to break where it is the weakest. So the crust has broken in all of those places. On here, you see the black lines. Now, we are living right here in Georgia, and so we live on the North American plate. Most of the plates are named for what is sitting on top of them, like you can see the continents here, or the ocean, or in the case of these, it's a country often that is on the coast of the continent in which it sits next to. So we're going to talk about how the plates move, because that movement causes a lot of things. So let's look. We've got arrows moving towards each other. We have arrows moving next to each other. And then over here on this side of the Pacific plate, we have arrows moving away from each other. So if you look at the key, you can see that there are 3 ways that the plates move. Now we're going to look at the types of the boundaries. So where the 2 plates meet, they form a boundary. There are 3 types of plate boundaries based on how the continents move. So in this section right here, you're going to type the word, or you're going to write the word move, M-O-V-E. So we see when they move away from each other, it's called a divergent. Convergent is when they move towards each other. And transfer is when they move side by side. Now each of these creates a different kind of event on the surface. Convergent boundaries are where 2 plates are pushing together. So in the box, I want you to draw those arrows facing each other. And we're going to identify those 3 types of convergent boundaries. So this is the more complicated type of a plate boundary. Because depending on what crust is coming towards each other, where if it's oceanic and continental, we have 3 different combinations. So ocean and ocean, that's going to form a trench at the boundary. Oceanic and continental will also form a trench at the boundaries. When we did our model today, this was what was on the outside. The outside slits represented a trench, and we had that forming. We had a trench forming when the oceanic crust subduct down underneath of the continental crust. And then when we have continental and continental, it forms mountains. All right, so convergent, the first one is oceanic and oceanic. The one oceanic plate pushes down under the other. That's called subduction. That's a word you need to know. It means one plate goes down under the other, and it pushes down into the asthenosphere. So you can see here where the plate pushes down, that's where a trench forms. This movement creates heat and melts magma, forming volcanic islands. And so if we watch this, and you have a picture I want you to label on your notes, the oceanic plate pushes down underneath of the other oceanic plate. When it pushes down, it creates friction and a hotter spot. So as the crust goes down, it goes from being cool, warm to hot, it melts. As it melts, the magma starts to rise. If it rises enough, still liquid, it's going to erupt And if it erupts enough times, it will form a volcanic island here above the ocean water. So you can watch that over a couple of times, but we are going to move forward in the notes. But you can rewind and watch over. All right, our next type of boundary is a convergent collision, where we have oceanic and continental. Oceanic plate sinks or subducts below the continent, and the continental plate slides over the top of the oceanic plate. This also, as we can see here, forms a trench on the ocean floor. It's a very deep place on the ocean floor. Now this type of movement does the same thing. We've got the oceanic plate subducting down under the continental plate. So you want arrows on that. You want to put arrows on your picture. You want all of this on your picture, on your notes. Friction is formed, and then you have the crust cooling. It gets warmer because of the friction and hot, and it melts down here in the asthenosphere. Magma rises, and as it rises, it melts more crust. If it reaches the surface and erupts, then we're going to have volcanoes on the shoreline. And this is an example of the mountains that formed on the western side of South America. Now we have the convergent collision of continental and continental. Now we have no subduction here because you have big, thick crust. So instead of one going on the other, they slam into each other and they buckle and fold the crust, like our Appalachian Mountains formed this way when Pangea was created. Also, the Himalaya Mountains are forming when India broke free and moved up to the Eurasian continent and slammed into that continent. And those mountains are still building today. Now, the other type of boundary is called a divergent boundary. And in a divergent boundary, you have two plates that are moving away from each other. So put some arrows there. And also, I want you to fill in, you see, between them, it pulls the crust and makes the crust thinner and sinks down. So that creates a rift valley. Now, you may recognize this, I hope, as the type of boundary where we talked about seafloor spreading. So we can see here in the picture of our moving seafloor where you have magma right here rising, filling in, causing the seafloor to push. So this is what happens in the ocean floor. If this happens on land, over here to the right, you will have a sinking in valley. Then if that moves to the edge of a continent and starts filling in with water, as it did in Pangea, you end up with a new ocean basin. Now we see that we have this happening here in Africa. So in Africa, we have the Great Rift Valley where there's a divergent boundary. You can see the divergent boundary that created the Red Sea. Remember when we did Pangea, we put the Arabian Peninsula here right next to Africa. So there was no Red Sea then. And this is an area here where that Rift Valley is forming because of a divergent boundary. Now the last type of boundary is the transform boundary, and this is the easiest one of all really to think about. It's when the plates slide past each other in a side-to-side motion. Now a lot of times they are going in opposite directions, and an example of this type of fault is the San Andreas Fault. And in your picture on your paper you can see that fence post that is separated. Well, that actually was together at one time, and that happened when there was movement on the San Andreas Fault during the 1906 earthquake in California. Be sure to get your arrows in the boxes. And that's that picture right here that shows the separation of these two fences that were once together. There have been some incidences when an earthquake has moved the earth 5 to 6 feet all at one time. Normally, it's a much slower movement. Now, how is all of that movement taking place? Well, we looked at one example of movement, and that was from the seafloor spreading, where the molten material filled in and pushed the seafloor. We also have another action taking place here under. Let's go back here. And this movement right here is the movement in the asthenosphere that is causing the crust to also get pulled. So it's pulling and dragging it along. Excuse me on that. I don't know why that popped up. Okay, that just stopped the whole program. All right, right here at the very last section, how do the plates move? Well, those convection currents that you saw in that picture help to move the crust along. It pulls it around. And what creates a convection current is when you have hot molten rock that's less dense that's going to rise. So remember, the heating place in the earth is the center. So at the bottom of the asthenosphere, that molten material is heating up. When it heats up, it becomes less dense. When it's less dense, it rises away from the heat source. It's going to cool off, and when it cools off, it becomes more dense and it sinks. So you have this flow of molten material that creates a convection current. Well, make sure that you get this written in the boxes also. We're going to talk more about this in class tomorrow. So that is the conclusion of your notes.